Welcome back to this section of our systems of equation problems. So in this tutorial, I'm going to take you through naive Gaussian elimination problems specifically. To solve 2x minus y plus 3z equals 9, x plus y plus z equals 6, x minus y plus z is equal to 2. If this is the first time you're visiting this channel, kindly subscribe and don't forget to watch this video to the end so you understand every part of the video. So we have to solve this equation. Solving means you have to find the unknowns x, y, and z, right? Using the naive Gaussian elimination. In our previous video, we talked about the algorithm, how to find the unknowns using the naive Gaussian elimination. I will entreat you to watch or visit that video. So to start, let's write our solution. You write your coefficient matrix, right? Yeah, so our coefficient matrix together with our B gives us our augmented matrix. So let's see, row wise, this will represent the first row. So I'll have this represent the first row. I'll have 2, neg 1, 3, bring a slash 9, right? The second row also come 1, 1, 1, 6. The next row 1, negative 1, 1, 2, like this. So once you've written your augmented matrix, the next thing to do is your forward elimination, which is done using the row operation as well as using the multiplier. Okay, so at this point, we are converting our augmented matrix into an upper triangular matrix, specifically the coefficient matrix. That's the goal of naive Gaussian elimination. We want to convert this to an upper triangular matrix. So how do I do that? I can do this by turning this one to 0, this one to 0 in our first column, and also turning my last entry in my second column to 0, and that is all. So how do I do that? So first of all, this represents row 1, this is row 2, this is row 3. Okay, so we are going to perform row operations to eliminate that. This is 1. What do I do to clear off this one? Using my R1 as my pivot. So I'll have to divide my row 1 by 2, then subtract it from row 2. Is that not it? So my row operation becomes my row 2 minus my row 1 over 2, and this all goes to row 2. Okay, because whatever result I get, I should put it as row 2. So at this point, I'm going to have my row 1 remain the same, 9. Then row 2 becomes what? R2 minus R1 over 2. So 1 minus 2 over 2, which is 1, so 0, right? Then I'll get 1 minus, so I'll get, let me write it here. Let's say 1 minus, then this becomes negative 1 over 2. Is that not it? So 1 plus half, which is 3 over 2, giving us 3 on 2. Then finally 1 minus 0 on 2. So 1 minus 3 on 2. So if you have 1 minus 1.5, you're getting negative 0.5, right? So negative half. Then this is for this entry. Then the last row remains the same, 1, neg 1, 1, 2. I have 6 here, so 6 minus 9 on 2. 6 minus 9 on 2, what do I get? So 6 minus 4.5 will be giving us 1.5, which is 3 out of 2 here. So at this point, I move straight to the second row operation to eliminate this as well. So to eliminate this as well, I have to divide my first row by 2, then subtract it from my row 3. So my row operation is row 3 minus row 1 over 2. All should go to row 3. Okay, so I'll have 2 neg 1, 3, 9. Okay, then I continue from here. 0, 3 out of 2, neg 1 out of 2. Then here is where I apply the operation. So 1 minus 2 over 2, that gives me 0 here as well. Then negative 1 minus, okay, let me use this one. Negative 1 minus negative 1 on 2. Negative 1 on 2. So negative 1 plus 0.5, right? Plus 0.5. And that will give me negative half, right? Negative 0.5. So negative half. Then when I come here, 1 minus 3 out of 2. 1 minus 3 out of 2, giving me this is 1 and this is 1.5, negative half also as here. Then I'll come here. This one has 3 over 2 here. So the last one, I'll have 2 minus 9 out of 2. 2 minus 9 out of 2. So 2 minus 4.5, and that is giving me negative 2.5, which is what? Negative 5.2, right? Negative 5.2. So that gives us this, and we are almost done with our forward elimination. So we are left with removing this here, removing this. So how do I remove this here? I'll do this by considering only the 2 by 2 here. We only consider here the 2 by 2 inside, not the 3 by 3. So at this point, this becomes my root 2, it's still root 2, and this root 3. So what do I do to this so that when I subtract or when I add, I can get rid of my half here? How do I do that? So simply, you just take negative half divided by 3 out of 2. What am I getting? So like half times 2 on 3, right? So which is negative 1 on 3. Meaning when I multiply negative 1 on 3 by my root 2, I can eliminate this. So let's see. Negative 1 on 3 by 3 out of 2. This will cancel and I'll have negative half. Is that not it? So meaning it will become the same as root 3. So whatever you do is the elements you want to eliminate over the one which is our pivot. Initially the row 1 was our pivot, but after the first set of elimination, our second row becomes the pivot here. So this is the pivot. So this over this gives us the multiplier, what we call the multiplier. Okay, so negative half over 3 out of 2 give us a multiplier, negative 1 on 3. So my row operation simply becomes root 3 minus negative 1 on 3 multiplying what? Negative 1 on 3 multiplying my row 2. Okay, so row 3 minus negative 1 on 3. So let me make it just when I add, because when I multiply this by it will become the same. Okay, so I'll just subtract this. So this becomes row 3 plus 1 out of 3 row 2. Okay, so now at this point I'll have to write the result of this row operation. All this should go into row 3. So I'll reproduce this and I'll have 2 neg 1 3 9. I'll have 0 3 out of 2 neg 1 out of 2 3 out of 2 0. Then now you multiply 3 out of 1 out of 3 by my root 2. What am I getting? 1 out of 3 by 3 out of 2. So cancel, I get half. Then I'll add it to root 3, negative half. That will give me 0. Then I'll multiply the same 1 out of 3 by this. I'll have negative half by 1 out of 3, give me negative 1 on 6. And I'll add it to what I have here, plus negative half, right? So negative 1 out of 6 plus negative half. What am I getting here? So like 6, like 1 out of 6 minus half, you just multiply here by 3, here by 3. And I'm going to get negative 4 on 6, which is negative 2 on 3. Okay, negative 2 on 3 here. Then the same for this, I have here like I have here to be 3 out of 2. So 3 out of 2, let me cancel this. 3 out of 2 here times my 1 out of 3, giving me 1 out of 2, right? Then I'll add it to what I have here. So I'm having negative 4.5, negative 2.5, and I'm adding another half to it. I'm going to get what? But this is positive, so I'll have negative 2. Is that not it? I'll have negative 2, right? So let me do it. So I'll have minus 1 out of 2. So I'm having like 5 on 2 plus, so negative 2 as I said. So at this point we are done with our forward elimination and we've got our upper triangular matrix. So the next thing to do is our backward substitution, which is giving us this one. You multiply it by the variable given was xyz, right? So we are going to have it's this manner: z, y, then x. Is that not it? So negative 2 on 3 multiplying z, that's why we call it backward substitution, is equal to negative 2. So z will be equal to negative 2 by 3 over negative 2. Then we have z to be equal to 3, right? Once you have z to be 3, I can come to my second equation. My second equation is the same as 3 out of 2 y minus 1 out of 2 z is equal to 3 out of 2. Remember, as I said, the order z, y, x. So once I have this, I'll replace my z with 3, and I'm going to get 3 out of 2y minus 1 out of 2 multiplying 3 is equal to 3 out of 2. This is 3 out of 2. I'll go and add it here, 3 out of 2 plus 3 out of 2. So 3 out of 2y will be equal to 3 out of 2 plus 3 out of 2. They have the same base. You add the power 6 on 2, which is 3. Okay. So I'm getting 3. So 3 out of 2y is equal to 3. What is y? Y will be equal to 3 by 2 over 3. So y is 2. So therefore, my y is equal to 2. When my y is 2, I know that z is 3, y is 2. I'll go to the first equation. The first equation is 2x minus y plus 3z is equal to 9. I don't know x, I know y minus 2. I know z to be 3 equals 9. This is 9. This is minus 2, giving me what? 7. 2x is equal to 9 minus 7. So 2x will be equal to 2. Therefore, s is equal to 1. Therefore, my solutions using Gaussian elimination is s is equal to 1, y equals 2, z is equal to 3. Thank you for being with me in this video. Kindly like and share.